Okay, so this is something that all of you are expected to be able to do. Make y the subject. So after all the working, I need to end up with y equals to something. Right now on the left hand side of the equal sign, I've got 5x plus 2y. I need to get rid of the 5x. And I do so by subtracting 5x. So the same 5x plus 2y. This is the same equation. Now I'm going to subtract 5x on both sides so that they remain the same. They remain equal to each other. After I subtract 5x, then they are gone. They disappear. I'm left with 2y. 2y equals to 3 minus 5x. But remember, I need y to be equal to something. So what I need to do is to divide by 2. So 2y over 2 equals to 3 minus 5x over 2. Nothing actually changed. It is still the same 2y equals to 3 minus 5x, but on both sides I divide by 2. So by dividing by 2 on both sides, my left hand side becomes just y. Y equals to 3 minus 5x over 2. And that's the answer. Done? Okay, now we have a circular field diameter 160 feet. Feet is another unit of measurement for distance used in US and some other countries. But we use meters and centimeters and kilometers over here. So they want to find in feet the circumference of the field. Okay, there are two formulas for circles that you know. What are they? Pi r squared. What is the other one? Pi d or 2 pi r. These are the two you know, right? Anybody confused over which one is the area, which one is the circumference? Yes, some of you are still confused. So what is one way to identify which is the one for area and which is for circumference? Area got square. Your area is in cm square, in meter square, kilometer square. This is the one that has a square. So this is the one that is for the area. The one that doesn't have the square is for the length. Okay, so that's one way to remember. They want us to find circumference. Therefore, we need this. Pi times d or 2 pi r. D is for diameter, 2r, r for radius, so 2r will also be the diameter. Now we are given the diameter over here, so we use pi times diameter. Circumference, pi times 160. So use our calculator, 160 pi. We get 502.65. Then we need to round it off to 3SF. Because this is not exact. Show me what's the 3SF over here? 50? 3. 2 or 3? 3, yes. 503 feet. This is the 1 mark. Here we have 1 mark. Now they further tell us that 1 foot is 30.48 centimeters. Is that the length of your foot? Roughly about there, 30 cm. Find radius in meters. Find the radius in meters. Okay, so we need to have the radius first. If the diameter is 160 feet, radius 160 over 2, which is 80 feet. Okay, that's the radius in feet. But I need to convert it to meters. I can't do so directly, but they did tell us that 1 foot is 30.48 cm. So we can convert this to cm. 80 times 30.48 to give us 2438.4 cm. Right? We're converting the feet to cm first, because that's the conversion they gave us. And then now, as Singaporeans, we all know how to convert cm to meter. So what is the value in meter? Divide by how much? 100. So we get 24.384 meters. Is there a need to round off? Need to round off? No need. This is an exact number. We are not estimating anything. Okay, next one. We've got two flasks. They are geometrically similar. This is a keyword. It means that the ratio of their length is all the same. So the height over here 8 and this is 12. This radius is 5.4. They want you to find this. I'll make the question a little easier first. Make it a little easier first. Let's say this is 16 cm. Okay, you don't make this change, just for explanation only. If this is 16 cm and this is 8 cm, then the larger one is double of the smaller one, right? It's double. So if this is 5.4, what do you think R is going to be? What's the working? 5.4 divided by 2. Okay, so that's how it works. Now if this remains as 12, and let's say this is no longer 8, let's say this is 3. So the larger one is how many times of the smaller height? 4 times. So what should we do to get the value of R? Divide by 4. Okay? So that's how it works. Because they always have the same ratio. So now they want to find the height, ratio of height of B to A. B to A. So the answer will be 12 to 8. B to A. But is that the final answer? Need to simplify, right? Divide by what? 4. Okay, so we get 3 to 2. Should I write units? No need. Ratio, no units. Oh, sorry. 3 to 2. Okay, so what this means is that this 12 cm, if I divide it into 3 parts, then I will get 4, 4, 4. Then over here, I divide this into 2 parts, I get 4 and 4. 3, 1, 2, 3 units, 2 units. Can you see that? 1, 2, 3, 1, 2. So that means this 5.4 can also be divided into 3 parts. And this R over here will be the same. 2 parts. 3 is to 2. It is always 3 is to 2, 3 is to 2. Okay, let's see. Yeah, and expected they wanted us to find the radius of A. Okay, so we say that we can do it in a few different ways. By drawing the diagram like this, I know that the radius is going to be 5.4 divided by 3 parts, then I multiply by 2 parts. Can you see that from the diagram? Okay, so 5.4 over 3 times 2. Times 2, yep. 3.6 cm. Okay, before you flip over to the next page, I want to show you how, next question. Before we go to the next question, I want to show you how we used to do this in class without drawing diagram. What we used to do was height of B over, oh no, we want to find A, right? We want to find the radius of A, so radius of A over radius of B. Radius of A over radius of B will be height of A over height of B. Then we fill in whatever we know. So we want to find radius of A. We don't know what that is. Radius of B is given to be 5.4. The height of A is 8. Height of B is 12. So from here, radius of A will be 8 over 12 times 5.4. And we get the same answer of 3.6. So this is the format that we used to do for our practices in class at the start of the year. Now I'm telling you that you can also do so with the diagram, by drawing a diagram. Okay, now question 9. We've got a right angle, we've got a triangle. With a right angle over here. This is an isosceles triangle because both sides are 14. So this perpendicular line will split our 12 cm into 2 equal parts. So it'll be 6 cm and 6 cm. So we want to find the unknown h. Okay, so now we are going to make use of Pythagoras theorem over here. Pythagoras theorem is nothing scary. It's just 6 square plus h square equals to 14 square. Okay, there are 3 sides to a triangle. Something square plus something square equals to something square. Obviously, the last one must be the largest, right? Because we are adding 2 small numbers to become the larger number. So the last one must be the largest. Out of this is a triangle. Which one is the longer side? 14. Confirm it's going to be 14 over here. Now the other 2 blanks, you have no choice. It's going to be 6 and h. No choice. So now make h the subject because we want to find h. So 6 square is 36. Plus h square equals to, let's see what 14 square is. 196. We want to find h. So h squared plus 36 is 196. H squared itself must be, we take away 36 on both sides. Minus 36, minus 36. 196 minus 36, 160. So h squared is 160. H is going to be square root 160. Then you see this number? Is it exact? Is this an exact number? Then what do we have to do with it? 3 as at 12. Huh? Oh yeah, 2 decimal place. They said 2 decimal place. Thank you. 12.649. This is 3 decimal places. So we round it off to 12.65. Okay, so the answer 12.65 cm. Okay, now this is on properties of parallel lines. Let's do a recap. Are you all introduced to these 3 shapes? Okay, so we've got parallel lines over here. We've got parallel lines over here and parallel lines over here. So in all 3 cases, we've got a pair of parallel lines with another line passing through each of them. So there are some angles that we need to identify. So this is angle A, let's call this angle B. What is the relationship between angle A and angle B? Even if you didn't memorize right, you look at them. Do they look the same? So we say that A equals to B. But what is the reason? Corresponding angles, parallel lines. Okay, these are corresponding angles. They correspond to each other. They are the same. Now the next one over here, let's try this. Angle A and angle B. What do you think is the relationship between angle A and B? Same, right? They look the same. A equals to B. But what is the reason? This time it is alternate angles, parallel lines. They are alternate to each other. On the other side, alternate. Okay, and as for the last case, let's call this A, let's call this B. Does A look like B? Chang Hui, do they look alike? Does A look like B? Does A look like B? Do they look like they have the same size? Look only. Do they look like they have the same size? Yes or no? No, you have to. You have to look and judge. Is the angle the same? No, right? They are not the same. So can you tell me A equal to B? Cannot. So these two, we have A equal to B, but this is not A equal to B. Then what is the relationship? Well, what about 180? You mean this is 180, this is 180? Okay, they add up to be 180. A plus B is 180 degrees. Okay, and we say that they are interior angles, parallel lines. They are on the inside. They are interior angles. So when we do angle questions, we look out for these three shapes. The F, the letter F, the letter U, the letter Z. Once you can identify these shapes, these three letters, we know that there are relationships, corresponding angles. These two are the same. Interior angles, these two add up to 180. Alternate angles, they are the same. When we come back to this question, we want to find the angle P. And we've got parallel lines. So what letter can you find over here? What do you see? What letter do you see? The letter F, right? But it is upside down lah. Can you see the letter F? Yes. Okay. Now, so this belongs to corresponding angles. A equals to B. So let's go back to this. Can you now tell me the value of P? What is P? 65. So P equals to 65 degrees. Sorry, no degrees. P is 65. P degrees is 65 degrees. But what is the reason? Okay, they didn't ask you to write the reason, but I'll just tell you the reason. They are corresponding angles, parallel lines. Okay, so this will be 65. The next angle they want us to find is angle Q. Angle Q over here. So besides parallel lines, there are two more properties that we need to know. A and B. Chang Hui, do they look alike? A and B? Yes, they are the same. A equals to B. We call this vertically opposite angles. Okay, in this case, we want to find Q. Let me erase all the extra irrelevant lines. want to find Q, huh? Okay, what's the value of Q? Also 65, right? What is the reason? Vertically opposite angles. They are vertically opposite each other. So Q is also 65. And finally, for the value of R. Okay, this one you should know. I will just erase this part. Okay, we don't need all this. What's the value of R? Why? Why 180 minus 65? They lie on a straight line. A straight line will be 180 degrees. So R is 180 minus 65. R equals to 180 minus 65, which is 115. So adjacent angles on a straight line. Nivian, you get everything correct? Okay, now, area of this trapezium WXYZ. So we need to remember the formula. Or is it given to us? In your cover page? No, right, it's not given. Area, half times the sum of parallel sides times the height. But this is the perpendicular height. So this being the trapezium, I've got my parallel sides over here. And 12 is my perpendicular height. Half, 6, 12, no, 16. So this is 1 mark. Find the area of the circle 2dp. So it's a similar question. We've got a diameter to be 12 cm. So the radius will be 6 cm. Okay, radius equals to 12 divided by 2, which is 6 cm. Area, pi times 6 square, pi r square. (113.097). But they want 2dp. 113.10, yes. Then they want us to find the area of the shaded part. Okay, I've got the area of the circle, I've got the area of the trapezium. I only want the shaded part. So I take away the circle from the trapezium. Do a subtraction. Area equals to 132 minus 113. Should we use 10 or 097? 10 or 097? Okay, we use 097 because it is more accurate. This one is already rounded off, right? Okay, this is also not very exact, but it is better than this. So let's use 097. Uh, 18.903. Then we round off again, 18.9. Okay, 3SF. Yeah, 3SF. because they didn't say raw to any certain number of figures or decimal. So you leave it in 3SF. Find the gradient of this line. So you get to choose 2 points, any 2 points you like. For example, I will choose this 1 point over here. I will choose this point. Just to make my life more difficult, I have to count more squares. But to demonstrate to you that this can be done. The gradient is given by rise over run. I have selected 2 points. I need to rise first. Rise from the bottom to the top. Start counting. 1, 2, 3, 4, 5. I rise by 5 units. And now I need to run. I am running to the left. Running to the left is running backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. I'm running backwards. So my answer is negative half. Or negative 0.5. So this is the answer. Now that we have the gradient, we can start to write down the equation. The equation will look like this. Y equals to mx plus c, where we have to find the gradient and the y-intercept. It is definitely going to look something like this. So the gradient, we already found that it is negative half. Let's replace it. Negative half. Y-intercept, go back to your graph. Where does it cut the y-axis? It cuts over here. This has a value of between 2 and 3 will be 2.5. So the y-intercept is 2.5, which is the same as 5 over 2. Since I'm using fraction, I'll keep it as fraction. Or you can write y equals to negative 0.5x plus 2.5. Here we have another table. Find the corresponding values. I see an x, change it to a big bracket, plus 1 over 2. X has a value of negative 1. Put it inside. Negative 1 plus 1, 0. This will be 0. Now x has a value of 4. 4 plus 1, 5. 5 over 2. Or 2.5, same thing. So this is done. Draw on the axis. Negative 1, 0, 1, 1. Negative 1, 0, 1, 1. I need another point. 4, 2.5. 4 and 2.5. So these are my 3 points. You have to have them, then you can draw your straight line. Okay, draw your straight line long. Do not just stop at the cross. And then you need to label y equals to x plus 1 over 2. Y equals to x plus 1 over 2. Use your graph to solve. Okay, now this, we already plotted this. Y equals to x plus 1 over 2. The next equation is y equals to 2. So I need to draw this on graph. The line of y equals to 2 is a level 2. So let's draw level 2. Y equals to 2. So now we are looking for the point of intersection between y equals to 2 and our new line. They meet here. It has a block 3, level 2. X equals to 3, y equals to 2. That is the solution. X equals to 3, y equals to 2. Then make sure you have this horizontal line. Alright, next one. I think this is the last question already. Right, is it the last question? Ask you. Oh, okay, same question. Okay, here we have cylindrical packaging for shuttlecock. It has a diameter of 6.5. Wow, this teacher like to keep setting diameter. Diameter 6.5, height 48 cm. So we're going to paste a label around it. Find the area of the label. So this is a prism. What I've always told you to do to find the curved surface area is to outline the perimeter. Can you please do that first? Outline the perimeter of the cross-sectional area. And we're going to take this perimeter multiplied by 48 to get an area. So the two formula for a circle that we know, pi r square and pi d, which is the same as 2 pi r. So which is the one for area again? The one with the square is for the area because cm square. So now I want the circumference. I will be using pi d, which is 2 pi r. So I'm not using this. Circumference, which is also the perimeter, is pi times 6.5 cm. And now we're going to multiply this with 48 to get a curved surface area, just the curved part. Area 6.5 pi multiplied by 48. So 3SF 981. Why? Oh, sorry, 90. And now find the volume in cubic meter of the cylindrical packaging. Finding the volume. This time we will need to take the area. Area multiplied by the height. So the area will be given by pi r squared. Now I don't want this. But this area, if I find it from 6.5 cm multiplied by 48 cm, I will get my volume in cm cube. Right? Because this is cm, and my volume is going to be in cm cube. But the question wants in meter cube. So do you know how to convert from cm cube to meter cube? Do you know how to do this? How about this? Are you able to do this? cm to meter. This one you can answer, right? Divide by 100. What about cm square to meter square? Then you divide by 100 square. What about cm cube to meter cube? I divide by 100 cube. So now you know how to convert. Alternatively, you can change your 48 cm to 0.48 meter. You can change this in terms of meter, and we can find the volume. Then the answer will be in meter cube already. Same thing. Okay, but let us just practice finding our volume in cm cube first. Volume equals to pi r, which is 6.5 over 2 square. This is the area of the base. Base area. So we need to multiply by 48, which is the height, which results in 1592.79 cubic centimeters. But we have to change it to cubic meters. So we divide by 100 cube. But we need to round it up to 3SF. So this is our answer. Do your some marking and your corrections are at the end of this. Please go and count the number of marks you get. Okay? Okay, last question, part C. Now this box is going to be used to store the cylinders of shuttlecocks. And it has a measurement of 50, 20, 25. One cylinder has 12 of them. Find the maximum number of shuttlecocks that you can store inside here. So it is determined by the number of cylinders you can store here. Remember, the cylinder has a dimension of diameter 6.5 cm and it has a height of 48 cm. So if I give you this box and then a lot of these cylinders, how will you place them in this box? Will you let them stand up? Can I let them stand up? Why cannot? Yeah, this is too tall, this is 48 cm, this is only 25 cm. Can I place them this way? The cylinder this way? Also cannot, right? This is 48 cm, this is only 20 cm. You only have one choice, which is to make them lie down like this. Correct? So this is going to take up 48 cm already. Can I put another cylinder over here? Cannot, not enough space, only 2 cm left. Okay, I know that horizontally I only can place one. What about on this side? Looking over here, this is the eye. If you look at this side, how many tubes can we place? Is it just one or can I put more? Can I put more? Can, right? Can I put 2 already. Can I put some more? My drawing is very bad lah. But you have to think about it. Can I put some more? Okay, so this is 6.5 cm. Another 6.5 cm. This is a total of 13 cm, right? Then if I put another one, then I have a total of 6.5 times 3, 19.5 cm. I can put 3 over here. Then I cannot squeeze anymore already. Okay, so this is what it currently looks like. How about vertically? How many can I place? Also 3? 1, 2, 3. Can I put another one? Let's check. So 3 of them will be, just like we calculated, right? 19.5. If I plus another 6.5, 19.5 plus 6.5, I get 26. Oh, it's too much. So I only can put 3 over here. I only can stack them up 3. 2, 3, 1, 2, 3. So this is what I'll see from this side. And on this side, I'll see all the tubes over here. Okay? This is what it's going to look like. So how many cylinders are there? 9. There are 9 cylinders. Total number of cylinders equals to 9. You can draw it out over here. I will give you the full mark. If you can draw this out, I'll give you the full mark. So that's 9 cylinders. Total number of shuttlecocks equals to 9 times 12, because each can contain 12.